This video, I would like to discuss about partitioning in Postgres. Traditionally, there has been inheritance-based partitioning in Postgres, and after version 10 onwards, we have declarative partitioning. To appreciate the declarative partitioning, we take a first look into the inheritance-based partitioning, wherein you have a parent table, the root table, and then you have individual child tables, and then we need to actually manually create the glue that holds them together by creating a function and a trigger which ensures the data is being directed to appropriate partitions, and if there is any data outside the range, then the function errors out, raises an exception, and you wouldn't be able to insert the record. So let's dive into this. I've got I'm connected to a Postgres instance, wherein I've got this part schema is the name of the schema that I'm operating on. Currently doesn't have any tables, so I'll just go ahead and create the root or the parent table first to begin with. It's going to be a simple table. I'm going to call this as measurements. As you can see, it has the ID, log date, peak temp, and unit sales. I'm going to create the partition based on the log date. So yeah, this is the parent table, and then we'll create a couple of child tables. These are again individual child tables. We can again go back and see this is the parent table that was created. This is the child table, the first one, which is measurements y 2026 M01 for the dates between 1st January and less than 1st of February. Similarly, I'll create the second partition table. That's again an individual table at this time. As you can see, if you look at the metadata, we have three tables. This is what it is at this point of time. Yeah, I don't even have any indexes created on this. Just looking at this, there is no index created. What I'll go ahead and do is I'll create some indexes. This is just for the performance perspective, wherein we want the queries to be running faster. So we've created an index on the the name of this index is this, and we're creating this on the first child table. This is again individual at this point of time. Create the second index on the second child table, y 2026 M02. Now, just for before we create the glue, that is the function and the trigger, I'll go ahead and insert the record in the measurements table, right? And we can see here when we run the query against the part schema measurements table, we can see the record. But if I query that on the 2026 M01 part child table, it doesn't report anything. So yeah, so I'll go ahead and delete this record that I've just created. And I'll go back to creating the function and the trigger to ensure that the data that we are inserting gets into the appropriate child table. So here's a simple function that is making sure that if the log date is between 1st of January and 1st of bit less than 1st of February, it will be directed to the y2026 M01 table. If it is between February 1st and less than March 1st, it will be directed to the y2026 M02. And if it is anything out of the range, then it will raise this exception and asking to fix the trigger. So this is the function that is created, and then we will create a trigger. I've tried to research on if you can create this logic of ensuring the data gets directed to appropriate child table in the trigger itself, but seems like you cannot do that. And so I'm going to go ahead and create this trigger, and triggers get created on the table, so we don't have to specify the schema. And if it is before insert on this measurements table, for each row execute this measurements insert trigger, which will ensure that it is directed to the appropriate child table. So now going back to the insert that we had run before, I'll run this insert again. This time again I query the parent table first. Yes, it's there, and then I will query the child table. You can see this is there, right? And just to make sure it's not there in the second child table that we had. Similarly, we can go ahead and do an insert onto the second second row in the second partition. This is for 25th February, so we can see here it made it to the parent table. Then we can check. Yep, we'll check in a second, and it's there in the second. So this is how you would ensure that any data that is being inserted is being directed to the appropriate child table. And for just to cover this aspect as well, so I'm just going to insert into a range that is outside the one that is being defined in the function. So this is going to throw the exception saying data out of range, so we'll have to fix that function. So this is just getting to know how they would have created a table and create individual tables and then use that function and trigger as a glue to make sure they work as parent-child tables and parent partition tables, and how you would have to manually specify the range. If there was any data beyond the range, then you would hit exceptions. Um, in the next part, we will look at declarative partitioning, see how that life is simplified. To talk about the declarative way of partitioning in Postgres and see how life gets easier. So I'm going to create a partition table, which is going to be the same columns that we have, but it's going to be prefixed with PCL underscore just to indicate declarative. And we are going to specify the clause partition by range, and we specify the column on which we want this partition to be created. Then we will create the child partitions. I'm going to specify the same criteria here about the Y2026 M01 is going to be partition of the DCL measurement table, and the values are ranging from 1st of January to 1st of February. Similarly, we can see the second partition, just change the range that we want to vary here and then give the name as Y2026 M02, and see it's between 1st of February and 1st of March. So now we will go ahead and insert some values in here. So I want to use this insert into part schema, DCL measurement values, and specify this. So when I select from the part schema DCL measurement table, I can see the value is there. Then if I also query the partition here, 2026 M02, it's in, so you can see it's already there. So we didn't create any function, we didn't create any trigger. Just by using the declarative partitioning way, we can see that it has made its way to the appropriate partition that we want. We can again try to give a different value here for the first partitioning and see if that, so we can see this one made it to the first as well as to the, so this is where it is. Another thing that I leave it as a thought here is what, yeah, so this is just like providing the um, comparison between um, both the inherent partitioning or inheritance based partitioning and the declarative based partitioning. Yep, and yeah, I think the one thing that I would like just complete that here is if I were to insert into a month which is not specified in the child parent partitioning, then it will fail. So that's just to complete the test that we did in the inheritance based partitioning and the declarative based partitioning. I hope you find this valuable. Thanks for watching.